Hi students, so this is the last video of our roadmap, and in this video I'll be talking about a module called TIMEIT. So what it does, I'll show examples also. Okay, so let's start. So what is the purpose of this module? So this module actually helps us to evaluate the execution speed or execution time of a code snippet, and that's it actually. So let me show you a basic example. So to use it, you have to just import TIMEIT. So this is the module name, and the method name also same. So to do this, you have to do like this: TIMEIT dot method name is also TIMEIT, and it actually, I'll talk about the syntaxes, the ways. There are actually two ways to use TIMEIT. Let me show you first the example first. So TIMEIT, then statement equal to let's say here the code goes. So let's say num equal to 5. Yeah, that's all. And if I, okay, let me just run this. So python video 11.py. See, so this actually we have got from this. So what it does is it actually executes this code for millions of times, as I have not given any explicit value. So the default value is 1 million. Okay, so if you just give any value and the parameter is number, so number equal to 1000 or 10,000. So let me show you the output. Okay, so how it works is this function runs this code for this number of times, and this is the time that it took to run this code. So if you want to get average time for each iteration, so just divide this time by this number, and that's all. And this value is actually a float value, and this the unit is actually seconds. Yeah, and okay, so this is the purpose of this module. And yeah, so there are actually two ways. I mean, you can use one of two ways to use TIMEIT. This first way and basic syntax. So TIMEIT dot TIMEIT. So this takes actually three arguments. I have not given the first argument here. So first one is setup equal to some code. Okay, some code. Next is statement, as I have given here, some code, and the one is number. So number equal to number of iteration. Okay, so what is this setup code? So basically if you have some code that is needed to be run before this code runs, or for example, let's say you are dealing with numpy arrays. So and to use numpy arrays you have to import numpy module. So I mean, import numpy, you just put that statement over here, and just all the codes you want to run in the statement. So this is how it works, and this number of iteration, I mean this code is run for this number of iteration, and it returns the value. And one more thing to say, this setup code is not actually considered in this time, I mean the time it returns. So the execution time for this setup code to run is not actually considered in this time. Okay, and the another way is so second way is actually like this basic syntax. Okay, so this is actually okay. So to do this you have to do like this. So let's say I'm defining a function or my test function, and here I have put all my test codes. Okay, and yeah, that's all. So just so here you have to do like this: TIMEIT dot TIMEIT, and here first one is a function name if, and second one is from underscore main import this test function as the name I have given as if, and third parameter is number or number of iteration. That's all. Okay, so this name is actually, I mean any name can be given here, and if you don't know about this underscore main, I mean Python recognizes the current file that is being run as this one. So underscore main is the current file. So if you are for example if you are importing this file into another file and you are working on that file, so the name of this file won't be underscore main. Okay, so underscore main will be that file where you are importing this file, and this file's name will be the file I have given here. So this is how it works. Okay, so this is the basic syntax, and yeah, that's all. Okay, so before I leave, I want to show you something that I have said in my previous video, that I will show you practically that list comprehension takes much more time than generator expression. In my previous video I have shown you that generator expression is actually more memory efficient than list comprehension. So let's see that generator expression is actually time efficient also. So to show you, I am just using this way. Okay, I will be following this method. So let me first define two functions, list comp, and here I am just returning list comprehension. So le for le in, let's say, range for 1000. Okay, and another method, that is generator comp, and here I will be returning le for le in range 1000. Yeah, that's all. And here you have to just print. So print, first one is as I have said, so this is just a convenience, nothing else. And here from underscore main import list comp as if, and number is actually equal to let's say 1000. And oh, I have not, sorry, this is why it is not suggesting anything, TIMEIT. Okay, so yeah, and next one is for generator comprehension. So generator comp as if, and yeah, that's all. So let me run first. See, so this is actually why I'm getting 3 values. Oh, let me just comment out this one. See, just see the difference. So first one is the time taken by list comprehension, and second one is time taken by generator comprehension. So as you can see the difference. So this is the reason, and the reason behind this lesser time is, I have already discussed about this in my previous video. Just watch it. I am not discussing about all these things in this video. This is just for practical demonstration, and yeah, that's all. Okay, so the last thing is there is actually another method, repeat. So this is also sometimes used. So the purpose of it is, okay, so first let me show you the syntax. So TIMEIT dot repeat. So it takes basically, this method can also be used in these two ways. Let me show you just one way. So if you are using this way, so just let me copy this, Control V, and it takes an extra argument, and that is repeat. So let me just show you the output first, then I'll be demonstrating you. So yeah, that's all. Oh, I have to print this. So print. So what it does is, it actually returns a list. Okay, and the number of elements in this list is basically this number. So what is its purpose? It actually runs this code for each time. The number of iteration is basically this one. For each repeat value, the number of iteration is basically this 1000. So TIMEIT actually runs this code for 1000 times for each repeat, and it returns the value in a list. So yeah, sometimes these are helpful. Okay, so now if you are thinking that why we are not using just time module, because we'll just save the time before running the code, and then we'll run the code and then again save the time. So we'll just subtract 2 times and we'll get the time that the code took to run. So this can be a way to get the execution time of the code, but there is an issue actually, and the issue is the way the way it will be done will also include the time that are being taken by background processes. So there are some background processes also, and that time also will be included in this time. So sometime the result will vary. This won't be the desired result. So this is the reason why time module is not used actually. In next video I'll be starting with a new topic. Bye bye.